Hi friends, we are looking at chapter 5 and we're in section 5.4, which is compound inequalities. Let's get started by looking at some vocabulary words. Our vocabulary words are compound inequalities, intersection, and union. Compound inequalities are two inequalities that are considered together, usually around the same variable. So for instance, if I have x is greater than or equal to 2, and at the same time I want x to be less than, I don't know, maybe 10. This is considered a compound inequality if I want both of these things to be satisfied at the same time. In fact, it's usually going to be written in this way. X is between two numbers, and I'd say in this case this is saying the same thing here. 2 is less than or equal to x, while x is less than 10. Another type of compound inequality you will see is not with the word and, but with the word or. So in this case you could say I want x to be less than or equal to -2, or x could be greater than 9. In this case, there's no way to write this at the same time, like in the same way, so you'd leave it separated and you need the or. These are examples of compound inequalities. Certain inequalities have the quality of being an intersection, and others have the quality of being a union. Let's think about the concept of an intersection. If I'm having a party, and let's say Grace is going to be having a party as well, we decide to combine parties. An intersection of our guests would be the friends that we both have in common. So if I have a friend that Grace doesn't know, that person's not invited to our party. An intersection is an overlapping of two sets. In this case, the set I'm talking about is our set of friends. So in this case, we'd invite people probably from our class, because those are people that we know both in common and that are our friends. So an intersection in math terms is really represented by this case over here. So this is an intersection. Here, let's go back to that example. Let me scooch this down. If I go back to that example, there we go. Move this over one more time. All right, there. If I go back to this example, as I look at, I've got two things being satisfied. Not only is x greater than or equal to 2, but x also must be less than 10. So if you think about this as two sets of numbers, what we're doing is satisfying it by combining them both. So an intersection in math looks like two criteria being held at the same time. So there's the overlap. A union is kind of the opposite, right? So the union is the inclusion of all parts. Let's go back to our analogy about Grace and I having a birthday party or a party of any sort. If Grace is having a party and I'm having a party, if we just invite all of her friends and then you invite all of my friends and you bring them together, that's a union. So it's a union of two groups. Whether they overlap or not, you're bringing together all parts. Oftentimes when you see a union, it will have the word or. Think about it. If you come to the party that Grace and I are having and it's the union party where we bring our friends in, you know that each person is a friend of Grace or a friend of Dion's, right? Same thing here. When I have a situation like I do here, that x is less than -2 or x is greater than 9, I don't mind choosing an x value from either of these conditions. That's a union, and that's or. Couple other bits of information. This is often called a disjunction because when you graph it, you're going to get two separate paths. And this is called a conjunction because when you graph it, it's usually a unified graph. We'll talk about that later. Let's look at some examples. So here is example 1, we're looking at an intersection. And again, you notice that this intersection has a similar feel for the example that we had at the top. So when we look at this, we're saying that x minus 3 must be greater than or equal to -2 and at the same time less than 4. And then we'll look at graphing them together. So when I look at this, I am thinking about isolating x as I usually would, and to do that I need to add the opposite. So I'm going to add 3 to not both sides, but all sides. When I do that, I get a +1 is less than or equal to x, which is less than 7. When I have this inequality, again, remember this is just saying 1 is less than or equal to x, and at the same time I want x to be less than 7. So if I wanted to graph both of these situations, I get my number line, and I'm going to graph this one first. So I put a 1, let's say, here, and I know that 1 is included because it's less than or equal to, 1 is less than or equal to x, meaning x is greater than or equal to 1. So I'm going to do that, and I'm going to shade to the right. right? So that's that first graph. And just for helping out with color, I'm going to graph this other portion. I'm going to rewrite it in orange. That was terrible. Okay, I'm going to rewrite that and graph this guy here. So my 7 is here, open circle, and I'd be, since x is less than, I'm going to be shading to the left. So where do they overlap? What do they have in common? Well, they have everything from here to here in common. So to graph the union, or not the union, to graph the intersection, not union, the intersection of those two graphs, I'm going to do it over here in black. This graph right here is this. At 1 to 7, we're going from 1 to 7, closed circle at 1, open circle at 7, and everything in between, because that is the union of those, intersection of those two graphs. Sorry about that. All right, let's go ahead and look at another example. Hopefully I'll get the words straight next time. So here, we're going to write and graph a compound inequality. Human ears can only detect sound frequencies between 20 hertz and 20,000 hertz. Write and graph a compound inequality that illustrates the frequencies that humans cannot hear. So the cue here, or the most important thing, is to know that we're not talking about this, we're talking about what this doesn't cover, what humans cannot hear. So hopefully you recognize that humans cannot hear below 20 hertz. So I'm going to use H for humans, or hearing, and humans cannot hear below 20 hertz, so H less than 20, or what other category, or H greater than 20,000. And that's it. There's not much else for us to do. This is considered a union because we're uniting two different things together. We're saying, hey, this group or this group, in any category, humans won't be able to hear it, whether it's this side or this side. So we're joining those both together. Then that's a union. Let's see. I think example 3 is our last one. And here it is. We're going to solve and graph a union. So again, remember, unions often have the word or here, and we're going to solve these like we do any other type of equation. So I'm going to isolate my 2m by subtracting 7 from both sides. When I do that, I'm left with negative 2m is less than or equal to 13 plus a negative 7 is a 6. I'm going to divide both sides by a negative 2. When I divide both sides by a negative, I hope you guys remember that the sign flips. When it's an inequality and we divide or multiply both sides of our inequality by a negative, the sign flips. So we end up with, let me use my black pen again, we end up with m is now greater than or equal to negative 3. So this is one part of our answer. So we're going to include both because this is a union. We want both together. So let's go ahead and take a look at what's happening here. I'm going to subtract 12 from both sides. And I'm going to get 5m is greater than 25. At this point, I'm going to divide both sides by 5, recognizing the fact that 5 is positive. I'm not doing anything that's going to cause this symbol to change directions. 25 divided into 5 is 5. So I am left with m is greater than 5. So remember, this is not an intersection. I'm not looking for where they overlap. I'm just looking to say, hey, let's bring all of this together. So I'm going to graph each individually and bring it together. So here are my number lines, and here are my graphs. Okay, so now we see that m is greater than or equal to negative 3, and m is greater than 5. How do we bring them together? Because remember, unions, the party, we're bringing both groups of people together. We don't care about overlap. We're just bringing them together. What does that look like? That looks like the following. That looks like me saying, all right, negative 3, 5, on. So I got this one portion here, and I'm just going to graph the other one right on top of it together. So it's all together. So the ending answer to this is that it doesn't actually look like a compound inequality when we're done. It looks simply like this. X is, I'm sorry, not X, but M is greater than or equal to negative 3. All right. I know that this isn't the most straightforward concept. Union, intersection are kind of terms that we use differently in English than we do in math. However, I do want you to try to work through the problems, keep it in mind, and I look forward to talking to you soon and answering your questions. Have an excellent day.